Let's start section 1.7. We're going to talk about solving inequalities. Inequalities are similar to equations, and so we've already been studying equations quite a bit in this chapter, so it makes sense that we would finish the chapter with some inequalities. We'll study four different kinds. We'll study linear, three-part, quadratic, and rational inequalities. Notice we've already studied similar equations, linear equations, quadratic equations, and rational equations. Let's get right into the first type, the linear inequalities. Most of this should be review, so we'll go pretty quickly. We'll just work through one example, and that should be enough. If we want to solve this inequality, then we just need to isolate the variable x on one side of the inequality. Usually we leave the variable on the left side, but it doesn't really matter. We can subtract 5 from both sides of the inequality, and the plus 5 and the minus 5 cancel, and we're left with negative 3x is greater than negative 12. And then we can divide both sides by negative 3, and the negative 3's cancel, and we're left with x on the left side. On the right side, we have a positive 4. And in the middle, you might expect the inequality just to come down. But in fact, there's a special rule that says if we multiply or divide two sides of an inequality by a negative number, then the direction of the inequality switches. So this greater than here would become a less than because we divided by the negative number. Again, if we multiply or divide an inequality by a negative number, then the direction of the inequality switches. Maybe it's worthwhile to go out to the side and just remind you why that's true. If you start with an inequality that's true, say 2 is less than 4, that's a true statement. Then you come through and multiply or divide by a negative number. Let's just multiply by negative 5 this time. Then we have negative 10 on the left side, and we have negative 20 on the right side. And sure enough, negative 10 is greater than negative 20. And so the direction of the inequality switched. Okay, so there are several different ways. So let's go back to example 1 now. There are several different ways that we can write this answer. We've just written the answer symbolically. X is less than 4. We could also put that in set notation. We could write, let's see, set notation starts out with braces. And we want to say x is less than 4 in braces. And then there's a little bit of a formal structure in set notation. Here at the beginning of the statement, we state what the variable is, and then we have this vertical line here says, okay, now we're going to use that variable to tell you what the interval is, and that interval is x less than less than positive 4, excuse me. So we might write this out in words. We could write the set of all x, such that x is less than 4. And in this particular case, the words such that correspond to this vertical line in our set notation. Okay, so that would be another way to write our answer. And then we still want to use interval notation and also a graph. Let's do the graph first. Let's see here. If we just have the one variable x, then our graph is just going to be a number line. You know, if we had two variables, then we would use x and y axes, and we would plot points in the plane. But here, just one variable, so just one axis, or we just call it a number line typically. And then we'd like to label some values on that axis. So we put some tick marks here, and we can just start with 0 and 1, 2, 3, 4, 5, and then maybe one more. Let's just go up to 6. And then if we're saying all the numbers that are less than 4, all those numbers are to the left of 4, And so what we do is we shade the number line to the left of 4. And so we're just going to darken it in there. We'll try to make it neat. Sometimes this gets a little messy. And then there's still one issue about how do we show that that the number 4 is not included in the set, right? It's all the numbers that are less than 4. Well, that's not 4. 4 is not less than 4. So how do we omit the 4? Two good ways to do it. One way would be with an open circle. And then another way, which is pretty important, I'll take the time to go ahead and make this number line again. Bear with me. Another way to show that we want the numbers less than 4 but not equal to 4 is to use parentheses. And so that parentheses, that might seem a little odd to put parentheses on a number line, but that's how we do it. And with the parentheses there at 4, we're saying that we're not including 4. You know, I bet you remember that if we wanted to include 4 in our solutions, we would write x is less than or equal to 4. And then what would the number line look like? Then we would include the number 4 in our set of solutions because 4 is less or equal to 4. So over here in this first number line, we would shade in the circle at 4 to show that it's part of the solution. And here, instead of parentheses, we'd use a bracket. And we'll get to see an example of that in just a minute. Before we go on to that next example, let's just do one more thing here. Let's go ahead and write our solution in interval notation. And this may be the most important thing for us moving forward in the course. We'll use interval notation a lot to represent an inequality like this. So look here at our number line. The interval notation says that we're going to start out here at the left, whatever value this is, and we're going to go all the way up here to the right, whatever value this is, and we're going to include all the numbers in between. So if we're including all the numbers in between, we don't need to write any of them out. We just need to write the lower boundary and the upper boundary. And so if we, so what are those boundaries? Well, maybe it's clear at the upper end, at the right end of the interval, you have the number 4. What number is here at the left end of the interval, right? It's past -1 and past -2 and so on forever. So this is actually, this arrow says that we're going all the way to -infinity. And so -infinity is at the left end of the interval. 4 is at the right end of the interval. And then we just need to say if we're going to include the 4 or not. And since we're not including the 4, we have parentheses, just like we have on the number line. So that looks nice. And then are we including -infinity? Well, no. And the reason is because -infinity is not really a number. It's at the end of a number line that really has no end, that goes on forever. So we never quite get to -infinity, and so by that logic, we'll just use parentheses every time that we have infinity or negative infinity in our interval. Okay, so we finished example 1. Let's just back up real quick. There was a big idea. Let's try to hit the ideas again here. The big idea in solving was to flip the direction of the inequality if we multiply or divide by a negative number, which we did. So we got x is less than 4. And then over here, we wrote set notation. We've been doing a lot of that in chapter 1. Now this set notation looks a little bit different because the variable is actually written into the set notation, and because of this vertical line here. We went ahead and wrote out the solution set in words, and then with a number line, also known as a graph, and then finally in interval notation. Okay, let's go on and let's try a three-part inequality. Three-part inequality has, well, you might guess it, it has 3 parts. There's actually a less than or equal over here and a less than symbol over here. And so what does this say? This is equivalent to saying that 11 is less or equal to 3x minus 1, and 3x minus 1 is less than 17. So really what you have is 2 linear inequalities that share this common expression, this 3x minus 1. And so you might guess that it's a little more compact, or maybe a little quicker to write the thing as a 3-part inequality rather than 2 separate inequalities, and it might be a little quicker to solve it this way as well. The neat thing is that when you think about it, if we're going to talk about solving this now, we're solving this inequality and this one, and the steps are the same. Here in this first inequality, we need to add 1 and divide by 3, and in the second inequality the same. So what we can do is we can do all of that all at once for both inequalities. So let me show you what I mean. We're going to isolate x in the middle of this 3-part inequality. To do that, we have to add 1 to all 3 sides. And so then we have a 12. We have 12 on the left. We have a minus 1 and a plus 1 that cancel in the middle. And we have 18 on the right. And of course, the direction of the inequality didn't switch. And then one more step. Now we can go ahead and divide by 3 on all 3 sides. The 3's cancel in the middle, and we have 4 on the left and 6 on the right, and just x left over in the middle. This time we divided by a positive number, so once again the direction of the inequality didn't switch. We still have less than symbols. Yeah. And so here's our answer. It says that 4 is less than or equal to x, which is less than 6. And so we could write that in set notation, very similar to the previous example. We define our variable, we give the vertical line, and then we just rewrite that 3-part inequality. And let's see here. Maybe we'll save the words for just a minute. I guess we've said it. Let's write out the words in just a minute. Before we do that, let's go ahead and put this on a number line. So let's just have a number line with a few tick marks. It's usually nice to include 0 on your number line. And then, of course, we have to have 4 and 6 because those are the boundaries of the interval that we're talking about. And so let's see here. This says x is between 4 and 6. It says 4 is less than or equal to x. So that means that x is bigger than 4. That means the values of x are to the right of 4. And they're smaller, the values of x are smaller than 6. So we have a bracket on 4 and a parenthesis on 6, and they're facing toward each other, and the interval in between from 4 to 6 is shaded heavy to show that that's where the values of x are, the values of x that satisfy the three-part inequality. So a nice way to write this in words would be to write the set of all x such that x is between 4 and 6 and including 4. We say that it's including 4 because of the equal sign underneath that first inequality. It's not including 6, and you could write that explicitly, although it's not necessary. I think I'll just leave it as it is. The set of all x such that x is between 4 and 6 and including 4 and not including 6. The last thing we want to do is we want to write the interval in interval notation. And so what's the number at the left end of this interval? It's 4. And at the right end of the interval is 6. And then we just want to put the brackets to show that we're including 4 and the parentheses to show that we're not including 6. And we're done.